Yeah, good evening. I think in the last videos we started linked list concept. So the problem with arrays, we have certain issues are there with arrays. To overcome that problems, we are going for linked list. Okay. So what are the advantages of this linked list over that arrays are nothing but you can able to use random memory locations and you can increase the size like anything. So many advantages are there. And there are four types of linked lists are there: single, double, circular. Again in that circular we have circular single linked list is there, and we have circular double linked list is there. Okay, like that we have. So then in this, sir, what is the meaning of this single linked list? How we can able to represent this single linked list also we have seen. So every list, every node contains, every linked list or every node contains two parts will be there: data and then next. Data means to hold the content, next means which is used to move to the next pointer, that is nothing but next node. And I think in the diagram I explained very clearly, and we can perform various operations on this linked list. The basic application I explained, sir, something like how you can able to delete all these things. Anyway, full-fledgedly I want to take this linked list. So the following are the operations, so that we can perform on linked list. So these are very, very important even for the interviews also. So what is the first operation that I'm going to use here is inserting the data. Okay, inserting the data at the first location. So now second one is inserting the data at last location. Okay, now inserting the data at a given position. So I want this node should be inserted at a third location. I want to insert this node at a fourth location. How you can able to do that? Then sorted insertion. Okay, so sorted insertion in ascending order or descending order, both we will cover. That means at the time of inserting the nodes, the data should be arranged in ascending order. For example, if I am inserting 1, then it should be inserted like this. If you are inserting 5, it should be inserted like this. So when you are inserting third, sir, it should be inserted like this. In this style, the data should be inserted. Anyway, manually we have to write code for that part also we will see. Then traversing, or I can say displaying. So next and after that, getting size of the list, or I can say length of list, how many elements are there. So next and after that, sir, I want to reverse the list. So how you can able to perform a reverse operation? Then I want to search for an element, searching operation, how you can able to do. Next and after that, I want to delete. So deleting, so from first location, how you can able to delete. Then, sir, deleting from last location, how you can able to delete. Next and after that, so I want to delete, so from given location. Okay, location or position, from the given position, how you can able to delete. And deleting, okay, and deleting, so a specified element, how you can able to delete. And deleting elements, that means all the occurrences I want to delete. Okay, so then what is the next one here is I want to delete the duplicates. Deleting or removing duplicates. Suppose if any duplicate elements are there in my list, how you can able to delete. Okay, so next and after that, sir, next one, I want to copy the reversed list, and I want to make a copy of original list. Okay, how you can able to do copy operation? Sir, comparing two list objects. So how you can able to compare two list objects? Okay, so that comparison we are going to see. Then, sir, nth node finding nth node. So from nth node, from beginning and ending. Beginning and ending. How you can able to find out? As of now, these are the common operations that we can perform, but if any time being it permits, I will add a few more topics. These operations are very common for single linked list, double linked list, and circular single linked list, circular double linked list. But sir, maximum topics will be repeated. Suppose if you took searching algorithm, searching for a node in the linked list, it is common for all these four. That is, whether it may be single linked list, double linked list, circular single linked list, circular double linked list. This finding, searching, or traversing, or finding the length, some operations are very common. Anyway, just I will add one note and then I will bring that copy paste mechanism. Okay. So mainly you need to concentrate on remaining aspects. Okay. Sir, if you are very clear with these operations, we will start implementing a full-fledged single linked list program, sir. I request everyone to please confirm. Is it clear up to this? Everyone, please confirm. I request everyone to please confirm. Right. One second, sir. Please wait. Right. So let us take single linked list implementation. Okay, single linked list implementation. Sir, a big code we are going to get. So I'm going to take this complete code in a single file. Then I will append at the last. But anyway, let us see how you can able to work with this. Okay. Sir, I think in the last videos somewhere I explained very clearly, whenever you are creating a single linked list, okay, make sure that you have to create a nested class. We have to create a nested class with the name node. This node contains two fields. One is I'm taking integer data, and the second one is nothing but a next pointer. And whenever you are creating a object for this node, it will receive the data. So this data, current data will become this data, and this data, your next will be pointing to null. Okay, and make sure here I am going to create two special variables. One is nothing but head, which is always pointing at the beginning, and the next and after that I am going to take a size. Okay, like this I am going to maintain two pointers. One is nothing but head, another one is nothing but a size, sir. So what is this size? Initially it is 0. Whenever a node got created, then we are going to increase this size, and whenever a node got deleted, we will decrease that size. This is nothing but a sample template. So for any single linked list, we have a node which contains two parts. So this one is called as a head, maybe first node. Then so next field will be there, right, which is pointing to the next node. So next field will be there which is pointing to the next node. Sir, last node is always pointing to null. Okay, so this field is called as a data field, and this field is called as a next field. Like that we will have. So head means first. So size, how many elements are there here? 3. So node, data field, next field. So if you are creating any new node, so which should contain so data field and then next field as a null. Then whenever you are creating a new node, it will be incremented. Then you have to place this new node in the existing list in appropriate position, whether you are choosing beginning at a first or ending last, or you can insert at any position. That depends on your operation. This is nothing but the default skeleton what we have. Okay, right. Now, sir, whenever you are creating an object, an empty linked list will be created. So yeah, I'm not doing any other operations on this. Sir, I want to, okay, I want to implement some functions. Okay, what is the first function is nothing but, sir, I want to retrieve the elements. At the same time, I want to get the size. Integer, I am implementing one special function called get size. So which will return an integer value, this dot size. Okay, sir, as of now, let me create one empty single linked list. SLL list is equal to, I am taking new SLL. I created a new single linked list. Sir, my requirement is, can you please get our list dot get size? What is the size of my linked list? I think as of now, there is no elements, right? So it should return 0, right? Let me cross check whether it is working perfectly or not. Java C test.java. Okay, Java space test. As of now, the number of nodes are nothing but 0. So I want to display this. I want to add the elements. Once if an item is added, automatically we are going to create a new node. Once if a new node got created, then size will be incremented automatically. Okay, remember this. Now, sir, can you please confirm up to this? Just I have covered only two things. One is how to create node skeleton. Second one is a basic function, how to get the size. So if it is clear for you people, I will go with some implementation functions, sir. Can you please confirm up to this, friends? Do you have any doubts? Right, sir. Now, listen carefully, friends. From now onwards, you should put more concentration. I want to add the items. So we have to take add first function. So compulsory when you want to add at the beginning, so you have to pass some data. So my first step is nothing but I want to create a new node. New node is equal to, sir, new node I am creating with whatever data you have passed. Sir, at very first time, okay, I want to create a 12. So 12 is nothing but the data. Next field is anyway null. The name of this node is nothing but a new node. Perfect. Now you have to insert this new node, right? How you can able to insert? Sir, do you have any node other than this? No. So if you don't have any node in the linked list, okay, in the linked list, sir, what will happen? Sir, your head value will be there, right? Your head is pointing to null. Okay, your head is pointing to null. That means you have to check, array boss, in your linked list, is your head node is null? Means what? We don't have any elements. Then your head node will become new node and immediately return the task. Means what? Sir, here you can see. Here you can see. Sir, now we have one node, right? This head we are going to remove. Sir, now what we are doing? We are taking that new node. We are taking that new node and we are inserting here. Okay. So 12 and the next field is null. So your head will become new. This is the new node, right? This is the new node. Now onwards, this will become head. So now this new node also will be gone. That's all. Sir, this node is also got deleted. Like this we have. Perfect. Suppose again I want to insert one more node. Sir, again I want to insert one more node. Now, sir, the node will become something like a 10. Something like a 10. Next pointer is pointing to null, and the name of this node will become new node. Like this I have. Now I want to add this. Once if you add this, what will happen? This node will become, so this node will become, so at the beginning of this head, right? We have to insert at the beginning of this head. Now let me check how it is going to work. So else, that means if it is not there, then your new node will become, okay, your new node next will become head node. So then we are making your head node is pointing to new node. Like this I am taking. That's all. Task completed. Sir, now observe carefully. So we are taking again this node, we are bringing here. Okay, so already head is pointing to something. Now what we are doing, this new node is there, right? This new node is there, right? New node tends to next. Okay, new node tends to next will become this head. That means what? This pointer will be erased. Now it is pointing to the next. Then head will become new node. That means this is not head node now. Sir, now onwards your head node is nothing but this one. Okay, like this we have. If you add one more node, it will be added here. Like this we can add. So fast, sir. Okay, sir, I hope you people got a very clear clarity about this. Okay, can you please confirm, is it clear for everyone how to add the elements at first? Please respond. Is it clear for everyone? For every function I will ask the confirmation. I request everyone to please respond properly. Right, sir. Now, sir, next one, I want to add at the last. I want to add at the last. Void I am taking add last. Same, we have integer data is there, right? Sir, now the first step is the same. Node, sir, I am taking new node is equal to, sir, new node I am creating with the data, whatever we have. Okay, right. Then this condition is also same. Suppose if you don't have any node, then your node will become head and we are going to return. If it is not the case, if it is not the case, then what we have to do? Sir, you need to move to the till end. I will draw in the diagram, observe carefully. I have already one node is there with the content 11. This next node is nothing but 12. So this next node is nothing but 13. Like this I have. Last node is anyway null. This is nothing but I have head pointer is there. Okay, I have head pointer is there. Answer, please listen. In this class, you'll get the clarity. Please. Anyway, I'm repeating, right? You'll get it. Yeah, right. Now I want to insert a new node. Sir, already new node got created. I know the position. That's why I'm writing here. Sir, a new node got created with value something like 15. What is the name of this node? New node. Next field is null. Now listen what will happen. Sir, if it is not head, then what we have to do? Sir, I am going to create a new node called current. Like this, I am taking current node, which is nothing but pointing to head. That means what? Sir, here I am maintaining one current node which is pointing to here. So current node will be there. So current current node is there, which is pointing initially here, head. Okay. Now what we have to do, we have to move this pointer, sir, till this. So how you can able to move that pointer? Very simple. We have to write a while loop. While, sir, you have current node is there, right? Its next field is pointing to somewhere. Suppose if it is not equal to null, sir, till that, can you move this current node? Current node is equal to, so current node is equal to, so current node dot next. Okay, current node dot next. Now observe what it is going to happen. So initially this current node next field is nothing but a 12. Is it null? No, sir. Then your current node is pointing to this one. This will be gone. Sir, is this current node next field is 30? Is it equal to null? No, sir. Then your current node will point to this one. Sir, is this current next field is null? Yes, because here we don't have any link. Yes, its field is nothing but null. Then it will stop. Now, this current node is pointing to this one or? Yes, these links are gone. These links are gone. Now we have two pointers. Just we have to do linking of these two. Sir, how you can able to link after completion of this while loop? Sir, your current node is there, right? Its next field is pointing to your new node. There ends the matter. Now what will happen? Current node next field is there. That I am removing and just I am linking. That's all. So now even these two pointers are not required. That's all. A new node got inserted, right? Let us consider I want to insert one more node here. Listen carefully. I want to insert one more node here. Let it be 16. So next pointer is pointing to null and this will become your new node, sir. So initially, sir, your current node will point to head, right? This one. Sir, is next field is null? No. Then current node will become current node tends to next. Sir, is it next field is null? No. Then current node is equal to current node tends to next. Is it next field is null? No. Then it will move here. Is its next field is null? Yes. Then what we are doing? Current node dot next will become new node. This is the current node. Next field I am removing. So then which is pointing to the next. That's all. Now these references are not required. That's all right. Like this, the nodes are going to be inserted at last. Can you please confirm? Is this add first, add last methods? These two are clear for you people, guys. Please confirm, everyone. Right, sir. Now I want to execute this part up to now. Okay, I want to execute this part up to now. Sir, initially, so initially the list is empty, right? Initially the list is empty. How many nodes are there? Sir, we have 0 nodes are there. Now assume list dot add first. I am calling add first method. Sir, I want to add triple two. Then list dot add first of I want to add triple one. Later list dot add last of I want to add triple three. So next list dot add last of I want to add triple four. Then list dot add last of I want to add triple eight. Okay, so triple eight here. Let me take a triple seven and a triple nine. Like this I have. Okay. Now, how many elements got inserted? 1, 2, 3, 4, 5 nodes got inserted. Can you tell me what is the size of this list now? Yes, what is the size of the list? Yeah, you can unmute and you can speak sometimes. Oi, don't tell 6. It is 5. Okay. Let us execute and cross check really whether we are getting or not. Yes, you can see we have 5 elements are there. Now perfectly the elements got added, but where is that element list? Can we define? Yes. So can we define? Yes, happily. List dot, if you want, you can call. So print list method. this print list method, I have to define which should display all the elements. Void print list. Suppose, sir, initially, if your head is equal to null, that means what? There is no element in the list, right? So better to print system.out.println list is empty. When this situation will happen, suppose consider I didn't inserted these elements. Okay, so then if you call so list dot print list, sir, what it is going to do? It will print empty list saying list is empty and the size will become 0. Okay, sir, I have one item is there. One item is there. So, but I didn't implemented that function, right? So what will happen, sir? List empty is not getting. So that means some item is there. How to display that item? Very simple, sir. Node somewhere we have taken current, right? Let us take your current node is equal to head. So while your current node is existed, okay, while current node is existed, can you please print so current node dot data, because we are concentrating on data. Then what about your current node? Your current node will become current node dot next. That's all. So it will print all the elements. Let me check really we are getting the elements. Sir, we have only one is there. Okay, now I am removing this triple one. Sir, this triple one should be added at the first or not? Let me check. Yes, we got at first. That means insertion is working perfectly. Now remove all the comments. According to our way of insertion, the data should be there. So triple one, triple two, triple three, sir, triple seven, triple nine. Again it is coming. Why again it is coming? We are calling 2 times. Let me remove this. Now you can able to see. Sir, is the list came or not? I want to print this list in my own style. No problem. Here you can remove the println, and after this you can add some arrow mark so that it will be something like list. And at last you can refer that null. At last you can refer that null. Now see perfectly what will happen. Sir, this is nothing but my list. So I want to add 888 at the first. What function we have to use? So just we have to take list dot. So add first method I am taking by taking 888. Is this 888 got inserted at the beginning or not? Let me check. Yes, perfectly it is added. Like this we can take, sir. Now I want to show you this with the diagrammatically how this print function is going to work. So consider I have some 3 nodes are there or some 4 nodes are there like this. So next field is nothing but a null, and here this next node is nothing but this one. This next node is nothing but this one. This next node is nothing but this one. Assume the data is nothing but something like 1, 2, 3, 4. So this node will become what, sir? Always head. Is head is equal to null? No. Sir, node current node will become head. This one will become current. Okay. Sir, is current node is not equal to null? Yes, it is not equal to null. Print current node data. That is nothing but 1. Then arrow mark. Current node will become current node tends to next. That means now onwards, this is not current node. So this will become current. Sir, is this not equal to null? Yes, print the data 2. Sir, again current node will become current node tends to next. So next print that data. Okay, now current node will become current node tends to next. Print this data. Sir, now current node will become this one, null. Okay. Sir, is current node not equal to null means it will print the data. Since it is not equal to null, it will come out from this. At last we have null. Sir, this is the list, right? Yes, like this we are traversing. Can you please confirm, is it clear for you people, sir, how this print list function is going to work? Everyone, can you please? Next. So let me implement one more function. Okay. So I want to search for the data. Okay. I want to search for the data. So list dot I want to call search of. I want to check triple. Is it there or not? If it is there, I have to get output as a true. So if that element, whatever you are searching, if it is not existed, then I need to get a false. Sir, how you can able to perform searching operation? Whatever printing operation you have taken in the same way. I am taking Boolean search. It will take integer data. We are searching for this data. Sir, this particular concept only, this logic only I am taking here. Node current node is equal to head. Sir, until the current node is not equal to null, we have to do some operation. This one will become common. But what we have to do, array, in this current node, some data is there. Can you please cross check? Is it matched with your data? If it is matched with your data, immediately return true, stating that element is there. Then go to the next node. Check whether it is not equal to null. If it is not equal to null, check its data. If it is not matched, go to next node. Like that, if all the nodes completed, if this statement is never true, means what? That element is not there. At last, you can return false. That's all. Now I want to execute this code. Sir, as per my expectation, the result should be true and false. Perfect, right? So true and false. Like this search operation is going to perform. I think no need to explain with the help of diagram. I hope you people got a clarity, because it is the same like traversing, but at the time of traversing we are printing, but here we are checking the data is matched or not. Can you please confirm? Is it clear for you people, guys? I request everyone to please confirm. Is it possible to use binary search also? Yes, we can use, sir, I think, but it is very complicated, because too many pointers movements will be there. I think it is not possible. Okay. Right. So that's all, sir. I'm binding up the session. Sir, what points we covered among these? I think we have seen. Let us go with checklist. Let us go with checklist on this single linked list implementation. Insert at first is okay. So inserting the data at last is okay, implemented. Then traversing, displaying, we have finished. So then size also, so we have fetched. I think even this searching operation also we have completed, right? So tomorrow we will talk about how you can able to insert the node at a specified position. Suppose if you have 5 elements are there, if you ask to insert at third location, it should retrieve up to 3 locations and you have to insert. It is easy only. And after this, how you can able to use a sorted insertion. It is a new way of insertion. At the time of insertion itself, we will check where we have to insert, that position we will fix. Okay, you can store it in either ascending or descending. And even that reverse also, I think so, it is easy. Once if it is easy, I will explain. Otherwise we will see that what you can call that one at the last. Okay, because reverse is somewhat complicated, sir. Okay. Okay, we will see, don't worry, because we will finish complicated at the first. Okay, then deleting from the last, deleting from the first, deleting all these things, one fine day we will complete. Okay. Yeah, dear sir, why we have muted WhatsApp group is not allowing to message. Unable to ask a communicate. Please change the settings. Yeah, I think someday something happened. That's why I have given that permission. I didn't remember that. Yeah. So don't share that meeting links, sir, because that is a very problematic situation. Because so some people are unable to join. We are maintaining the attendance also for this. So the students who are joining, every information will be there. So that's why I request everyone, don't misuse that group, sir. Okay, please. I am enabling that option. Okay, but don't do that activity. Okay. Yeah. Right, sir. We will meet for the continuation tomorrow. Tomorrow we will discuss a few more things. Sir, these topics are very, very interesting. I request everyone to please practice simultaneously. Okay. So I request everyone to please practice simultaneously. Okay. So once if you are very good at single linked list, then double linked list, all those things will become very easy for us. Okay. Parallelly, you try to implement menu for this. Anyone. At last, I will take the menu from you. Okay. At last, I try to take a do while loop and ask the user to enter something, and you need to do this operation like that. You try to implement. Okay. Right, sir. Yeah. These are samples, sir. Once if you enter into this copying, comparing, reverse, this will become very, very interesting. There you will enjoy the flavor of linked list. Okay. Right, sir. We will meet for the continuation tomorrow. Okay. Right. Thank you, sir.